Hi, welcome back to part 2 of this module 1. So for this part, we'll be talking a little bit more about 4 topics. One is some of the enablers of AIoT. So AIoT, just like any other technology, did not just come out of a vacuum. There's definitely some factors that actually cause it to be emerging at this point in time. And secondly, we're going to talk a little bit more about 2 aspects. One is basically how AIoT, or the artificial intelligence of things, supports the 4th industrial revolution. The other is basically how it then enables the Society 5.0, which the Japanese government had envisioned and proposed at the World Economic Forum. And lastly, we're going to talk a little bit about the AIoT ecosystem that we would actually see. Okay, so without further ado, let's go into this. What are the enablers of AIoT? Like this. So first of all, AIoT is really something to do with the devices or the physical objects, right? The Internet of Things, after all, is the Internet of physical things. But we do observe that the kind of simple electronic devices that we may observe for what we see in the more basic IoT devices, they may not be actually suitable for the use of artificial intelligence of things. So one of the things that we would observe is that, my pointer here. So for the basic IoT devices, these devices, which you can see like somewhat like the Arduino kind of device, right? Simple devices, they just need basic computational power. So 8-bit microcontroller probably would suffice for many of this type of basic IoT devices. Basic amount of storage in the order of kilobytes, if not just a megabyte. Also, very limited communication capability in terms of very low bandwidth, and probably also very limited distance that they can actually communicate. And because these devices have limited capability, typically they do not really require sort of a Linux operating system or a more sophisticated operating system in them. They may just run on some simple firmware capability or proprietary OS that is actually customized for that particular microcontroller or microprocessor. So we don't observe a general operating system like Linux or Unix capability being embedded in these small devices. Now, the fact that they are actually using probably 8-bit processor because of the limited compute capability also limits the kind of OS they can run on them. Because Linux at least needs some sort of memory, virtual memory capability, without which I think on the more recent Linux kernel, unless you go back several generations, back to the very beginning, you will need to really rewire how Linux works without the virtual memory capability. So it's a bit of a difficult situation if you are going to use an 8-bit processor microcontroller and have Linux inside. So, but it's okay, it's fine, because for this limited IoT devices, they do not need a very sophisticated communication stack as well. So not having Linux is actually not a big showstopper for this kind of device. But for the AI OT devices, the artificial intelligence of things devices, they definitely need more computational power. So typically 32-bit or more than that, even 64-bit controllers would be order of the day. Some of these AIoT devices, especially those that need to process visual input, they need faster number crunching capability. So they would need some sort of embedded graphic controller or AI processor chip in them, besides just the microcontroller or the microprocessor. So things like the Jetson from NVIDIA, it has the embedded ARM processor inside, but it also has the so-called embedded version of the NVIDIA graphics chip inside, so as to acceleration of the AI computation capability. So they definitely need a lot more sophisticated computational power. Because of the greater computational power, they would also require more in terms of storage capability. And typically, the amount of data being generated by these devices is a lot more, hence the communication speed has to be larger as well. In terms of the bandwidth that they have and the transmission rate. They may not actually require a huge range unless we are deploying this over a wide area, but definitely the speed needs to be higher. And because of the enhanced features that these devices have, typically they would need as actually a better operating system to just manage all the system resources that are on the device itself. Most of these devices actually have some form of embedded Linux in it, which is a full operating system with virtual memory, with a device management control, etc. And Linux is actually open source, freely available software, although there is actually vendors who customize it for specific hardware devices. But if your device has the free and open source version available, like most of the ARM processors, they can use just the readily available ones. Then you don't need to actually use any of the proprietary versions. They are all derived from the open source root of Linux anyway. So with Linux, you can support many variety of devices. So for example, Linux is found in most cameras, smart cameras. You will also find Linux embedded in many of the routers and wireless gateway devices that you have. Sensors themselves, like a smart camera, they would also have embedded Linux as well. So the more sophisticated controllers that we typically find for artificial intelligence of things or AIoT, they would actually have Linux very much as part of the operating system environment for that device. So the devices shown down here, the Jetson from NVIDIA and the Google's version of their accelerator called the Coral Edge TPU, as well as the Raspberry Pi, and Intel has their own compute stick that goes with that. They are basically running far greater computational capability and having a operating system running on some version of Linux. So here we have this particular diagram that shows you the split between the different types of devices. So you find that the low-end devices, here's a list of some of them. Of course, this list is just gives you a sense of the kind of devices that are available, including some familiar ones for those who have been playing around with this a little bit. You have the Arctic from Samsung, and we have the Arduino, which is this very well known and very popular originally open source version, but now it's supported by a company. But it's still very much community driven and readily available. And some of the other more maybe not so commonly used, but those people who are working on this very low end basic IoT devices, they would actually be quite familiar with many of them. So the basic processors could be some sort of microcontroller, like what we find in the Arduino from the Atmel AVR series, or it could be even ARM-based ones, like some we see here, but they are the low-end ARM-based processors. Then we moving on to the more middle end, you can again start seeing more ARM-based devices, because ARM is actually more deployed for the more sophisticated devices rather than the simple ones. So you have the very popular one from Express IF, the ESP series, which has some embedded wireless controllers built in. So this one actually is from China, but it's quite well received by around the world. And we also find the more sophisticated versions of Arduino inside this middle range as well. Now for the high-end ones, we have mostly we have the Raspberry Pi variants. Raspberry Pi, as you may know, is actually basically based on the ARM 32-bit processor, which is actually I think now the latest one maybe actually ARM. Yeah, it's a more sophisticated version of ARM processors that actually are being increasingly introduced this, but the instruction set architecture is the same for all these different ARM processors. So this is one of them, and we have some that actually based on, I think not in this list, but there are some Intel processors that are meant for this high-end AIoT devices as well. In terms of the embedded Intel processors, but ARM has a very strong foothold, presence in this space because of the low power consumption that they have for their processors. So one of the things that enables AIoT is just the presence of this low power but very powerful IoT devices that have a long battery life, right? And they are able to do the kind of processing necessary with a very small form factor and still be able to fit the power requirements for IoT devices. Now, the second capability, I mentioned, and also actually the embedded Linux is actually a important feature. So in the past, when processors are typically having to run on a proprietary operating system, having some of the basic built-in capabilities such as a full TCP IP stack, be able to control various devices like Bluetooth, you have to actually have a significant amount of licensing costs for the device, not from the hardware chip itself, but from the operating system. So having that embedded Linux actually just puts everybody on a much better footing in terms of the general software support that you have on these higher end devices. So not only do you have higher end computational capability, but you have the base vanilla Linux capability already being made available for all these devices as well. So the other thing that actually really enables IoT and AIoT together is really the more advanced wireless transmission capability that's existing now in the 21st century. Now, IoT is actually not a new idea, but back in this day, right, when IoT first started, people were largely still talking about wired connections or even very basic radio, proprietary radio capability. But today in the 2020 decade of 2020s, right, the wireless capability is really very much more advanced. And basically we have a kind of radio or a standard-based radio for almost every single imaginable application scenario. But the range of capabilities that's required by the devices from themselves, they're actually quite different. So for basic IoT devices, they don't really need to transmit for a very long range, and typically the kind of bandwidth or bit rate that they require is also fairly low. So you may actually find that many of these basic devices, they do not even have a full TCP IP stack, which is a plus considering that the fact they don't have Linux for many of this, right? So if you need to have a TCP IP stack, you would actually have to license the customized TCP IP stack for that particular device, which may be a bit of a cost for the vendor or the manufacturer. So good thing is that for these many devices, actually, because of the way they transmit the data, actually, you don't really need a full TCP IP stack or just a minimal support in terms of the wireless transmission. And secondly, not only TCP IP is not available, and you would find that the common web-based protocols like HTTP and HTTPS are also not available. Right, so you don't have both of this as well. So instead of using this kind of communication protocols, typically these basic devices, they use some resource constraint protocol like CoAP, right, and other resource constraint protocols as well. They typically have lower bandwidth requirements, so they don't need something like 5G or a Wi-Fi connection. Something like LoRaWAN, low power, long range, wide area network connections. And something that from the 5G and 4G world, the narrowband IoT implementation of this, which is basically a machine-to-machine communication feature within the 3G, 4G, and 5G standards. They're catered specifically for IoT, narrowband IoT. So it's long range, but the transmission capability is much lower speeds compared with what you typically find in the 3G, 4G, and 5G networks. This NB-IoT continues to be part of the standard that has been placed for 5G. So you can rest assured that even though now we are in the age of 5G being rolled out around the world, this which was emerging when we had 3G and 4G continues to be part of the standard. So it's not going to be removed anytime soon. Now for AIoT, what we would typically have is that we need to have higher speed requirements. And because we're actually transmitting more complex information rather than simple bits of information across, having a full TCP IP stack is definitely a plus because, as I mentioned before, when you actually need to transmit more complicated information at a higher speed, and you need full TCP IP, you would typically need to license it from a vendor who has built it for that particular chip that you're using. But because most of these devices already come with the embedded Linux, so they would have full TCP IP as part of the Linux stack. They would have the web-based protocols, HTTP, HTTPS as well as part of the Linux embedded Linux that is actually deployed together with these hardware devices. Now, this kind of devices, because they are transmitting more information and more and more complex information, they would typically require higher bandwidths of a megabit or more in terms of transmission speed. Bluetooth, if it's low require, is required. Bluetooth low energy is one of the available one if the range is limited, but it's not too high the speed that they require, but they would need to have low energy consumption. Wi-Fi, the various forms of Wi-Fi, definitely wireless LAN. 802.11 wireless LAN is definitely one of the typical ones that are used, again, for limited range, just like BLE, rather than over kilometers. And then we have the wide area mobile cellular types of technologies, which are typically used for high bandwidth and also the long communication range requirements. Now, actually, for this area, 2G was used before, but 2G in many parts of the world, they are slowly being phased out. So that means that basically the use for 2G or GSM type networks will need to move over or migrate over to either use NB-IoT if they don't need such high speeds, or they would use the full 3G, 4G, or 5G capabilities to do the transmission. As you know, these are basically it's meant for multimedia, high-speed transmission over a wide area in terms of kilometers, rather than the two more range-limited technologies that were mentioned earlier. Now, the availability of this kind of wireless transmission in terms of different power consumption, different range, as well as different speeds available, definitely is one of the push factors to actually enable AIoT. In fact, many people or experts do say that 5G, with its enhanced capabilities of high power transmission, low latency, and as well as having the option to go low power as well, is one of the big push factors from the communications environment to enable the artificial intelligence of things. We'll talk a little bit more of that in the second module, where we talk more about the communications capability. But here's just a teaser to tell you that one of the enablers, besides as a device and operating system, is really the availability of a much better range of wireless capability in the technology stack today. And 5G is definitely one of the really big push, right? Big factors that will enable this AIoT. Maybe not so much for IoT, but AIoT will require this kind of capability. Here's a summary in terms of range, power requirements, as well as data rate for the different technologies. So if it's really very small range, Bluetooth, NFC, quite typical. Wi-Fi is also limited range, but in terms of power, it's really bad. But the speed is probably the best amongst these three. Then for longer range, we would have the LoRaWAN, okay, which is a technology low energy requirement, long range, wide area network. It's actually using the old, those people who've been around long enough will realize that this is actually the old, long time ago mobile radio bands that were used when the phones were bigger than your face. Yeah, so some of us are around from that era when mobile phones were first emerged, right? The car-based mobile phones, they were using actually these bands, but they have since largely been people 3G and 4G and 5G networks don't use these bands anymore, so they have been freed up, right? The spectrum for this has been freed up. Okay, but the range is very wide, but the speed is kind of low for data. It is adequate for voice, but for data it's kind of low, right? So but it's good enough for the basic IoT devices. Now the narrowband IoT, which I say is basically the 3G, 4G, 5G implementation for that substitutes for what was previously in the 2G network, low power, low speed but long range transmission. So you can see that it's quite well established for the extended battery life. It's really not too fast, but this kind of range is good enough for IoT, basic IoT devices. Then we have the 2G and now basically being increasingly replaced by 3G networks. It's not too great for power, but it's faster and it's quite long range. 4G, as some of you know, is basically really fast. Okay, more than 100 megabits per second, probably better than some of the early wireless or Wi-Fi LANs that we had. And then we have the 5G, which is being rolled out around the world now. Singapore being one of the countries that's actually have a commercial service for 5G now, but it's still not nationwide. The coverage is increasing, but we will soon have 5G in every single corner of Singapore. But this particular technology is, you can see that the speed is a big leap over what we are capable of in over 4G. We'll talk a little bit more about this in the module 2, where we talk about the specific advantages of the different communication protocols and networks. So this is the third factor, which I think really enables IoT and AIoT to emerge, and that is actually the shared computational capability within the cloud. In the past, whenever you want to deploy any system on a large scale, you would need to buy the infrastructure, purchase the servers up yourself, and then maintain them and manage them yourself, which is a big capital expenditure. With the cloud computing, actually, a lot of this capital expenditure or CapEx just becomes translated to just operational expense. And it helps companies to manage their service. So you only buy and use what you need in terms of the compute and storage and communication capability. You don't need to actually buy the physical machine yourself. And the shared infrastructure really helps to manage the cost. Right, so you find that for the IoT device, basic IoT devices, yes, you need compute, storage, and communications, but maybe at a more basic level. Whereas for AIoT, as you might probably expect, since the devices themselves require more advanced computational capability, we definitely need faster computational capacity in the cloud as well. So we do really need maybe some GPU-enabled instances, so that we can do the training for various machine learning models using these cloud services. And I'll talk a little bit more about the requirement for AI and training, what is meant by training, what's machine learning and deep learning in the third module, where we'll jump into quite detailed aspect of AI itself, the requirements for AI, and then but it's actually involved when we actually want to roll out an AI-based service. Then for the IoT, even IoT itself, actually, when all the data is actually collected from many devices over a wide area, the data that's being generated is quite frequent and it can be quite voluminous. So we definitely need some sort of big data management capability. In the AIoT case, same, we need to have this data management capability, big data management capability as well. In terms of event management, we need to basically support streaming data and the conversion of this streaming data into events. Same for AIoT. We would need streaming data and some sort of event manager as well. So remember earlier I said that for AIoT, we may be sending information in the form of events directly from the smart sensor. So instead of sending in the raw data as just streaming data, actually, we may actually be pushing up the events from the smart devices directly. For basic IoT devices, because many of them actually use more limited range, limited speed transmission capability devices in terms of the network that they use locally, so something like Bluetooth or even just local area networks, they would actually need some sort of gateway device for so there's a device that communicates with the gateway device, and that the gateway device will then gather or aggregate the information and then communicate this information as a group to the cloud. So that actually removes the need for us to actually put in a wide area communication to every single device. So the devices only need to send a limited range to the gateway itself, and then the gateway is typically a more capable device. You can even think of it as an AIoT device itself, okay, because it has definitely more processing capability. And then this gateway device, which is a bit like a sophisticated router, like wireless router, will then collect the information and send it into the cloud. In the cloud itself, because in the IoT cycle, between analysis and control is really a human that needs to understand the information. Typically, as part of the cloud computing service, you need to have some sort of processing capability and ability to also have a dashboard as well as visualize that information for the sake of the human analyst, who needs to understand the information and take the appropriate actions in terms of controlling or sending back the necessary control into the IoT network. Now for AIoT, as I mentioned before, you have those few services, and on top of that, you need to have stronger support for machine learning and deep learning in terms of how you will build the network, right? Build the model. So you would actually need to have GPU support, more storage capability, as well as versioning as well. And the other thing is that the model that are being built, if we have the model built, we can actually send the model down to the smart sensors and smart devices that we have at the edge, the other IoT, smart AIoT edge devices. There's obviously there are sometimes humans who be monitoring this, so there would be use of the dashboard and data visualization even for AIoT, so that humans can still take a look at the information. But because the processing is being done in a more automated manner now, they are not as critical, right? It's ready to support the humans, but a lot of decisions may be actually done autonomously or automatically by the AI capability inside the cloud, and then it will actually automatically send the commands or control down to the edge devices to close the loop. Right. So we're going to talk a little bit more about how AIoT enables the fourth industrial revolution. So if we see the evolution of the industry from the past, okay, so in the 18th century, we have the introduction of steam power and water power, and that really led to the first industrial revolution, where people started moving from an agricultural society and started producing things in factories. Then it moved on to mass assembly, where in the 20th century, where electrical power became available, we have mass assembly lines, and then instead of having just a very limited transmission capability for energy, with electrification, actually there was a huge transformation of the entire landscape in the world, because now power could be transmitted over long distances, and basically you can have very high concentrations of energy instead of what you used to have as a range, as a like a system of boilers, right, for all this steam power. Now you can have clean, simple energy transmission with electrical power. Then came the age of automation. In the age of Industry 3.0, so automated production, computers were introduced, as well as robots. In Industry 4.0, we see a migration from just the simple systems, separate systems that we see in Industry 4.0 to evolve to a smart factory where we have IoT sensors being embedded in all the different devices within the factory. We have machine learning being introduced as part of this to do more prediction, and the smart factory concept becomes a reality. And autonomous systems that are able to independently act in a more proactive manner. So you can see that really the AIoT, right, the kind of technologies that I've been talking about in the past few slides, really is what you would need to enable or support this particular fourth industrial revolution. So with machine learning, smart factory, autonomous or proactive systems, IoT, you need to have AIoT in place. So how AIoT enables smarter IoT? AIoT means more intelligent connected systems, ability to make decisions now, independent of just what humans can do. Artificial intelligence will also allow the maximum use of the data being processed by and collected by the various sensors and components within the IoT network. It will significantly contribute to their development. And based on the telemetry data, a device equipped with artificial intelligence will be able to control the entire system of connected, synchronized machines, manage individual devices, and even make decisions about self-repair when it notices that some of the parameters are abnormal. Artificial intelligence in industry is a real breakthrough thanks to this technology. Individual components of the machine part of a given factory will not only be able to provide data to people, thus signaling that something is wrong, but now automatically also take action to eliminate such a threat. So you can see that the whole idea is to really remove the need for a human in the loop for every single situation. Now, human beings have common sense and have actually a big range of capability that AI itself may not be able to have. But if it's a normal run-of-the-mill event that's actually happening, you don't need a human to make that decision. Actually, you can automate part of it. Yeah, not all of it, perhaps, but it will definitely save the humans a lot of work. And automated decisions are also tend to be more reliable than relying on humans who get tired or fatigued from having to process all this for long periods of time. Okay, simply put, IoT helps to connect the various devices together, but AI builds in the capability to take the right decisions at the right time. So IoT is the part that actually gets you the data, and in combination with the decision-making part, which is what we see with AI, you see that AI with IoT will give you AIoT. Secondly, I want to talk about this other concept of Society 5.0. So moving beyond in the Industrial Revolution 4.0, which is very much focused on the industry, right? Still the production, manufacturing environment that will be actually really transformed by this artificial intelligence and IoT technologies together to in the form of AIoT. But moving beyond just the manufacturing environment, does this technology in the forms of artificial intelligence of things also affect society as a whole beyond just the factory floor? So this is actually the vision that the Japanese government under Shinzo Abe had, right? So Society 5.0 is the Japanese vision for the future. It is a super smart or imagination society where technologies such as big data, Internet of Things, artificial intelligence, and robotics fuse into every single of the into every industry. Yes, but not just industry, but across all social segments as well. So it goes beyond the factory floor into society at large. So this is actually one of the key difference between Society 5.0 and the 4IR concept. So 4IR is very much restricted to more the industrial segment, but in the Society 5.0 vision, try to expand beyond just the production floor onto the other aspects of society as a whole. So again, you see the same evolution as mentioned before. So this dubbed the Super Smart Society, Society 5.0 was the vision shared by Japan in 2016. It was first presented to the Western world in the CeBIT 2017. In fact, it has been also presented to the World Economic Forum as well. So you can see that society, now we're talking about Industry 1.0, this is Society 1.0. So pre-industrialization, people were basically hunter-gatherers. Then we moved on to Society version 2, which is agriculture-based. Society 3, based on industry. Just this is basically Industrial Revolution 1.0. Then we have the Society 4.0, which is our present age, right? Our present age is very much an information, knowledge-driven economy. And then the next stage will be actually a society where AI and those technologies that we're talking about, AIoT, they would be actually part and parcel of this new form of society where it is the super smart society. So you can see some parallels between Society 5.0 and Industry 4.0. But you can see that for the Industry 4.0, the focus very much on a combination of both physical as well as like your sensors, right? In your IoT system, the physical systems, physical devices, and the cyber or the virtual systems that are processing this information, the cloud, AI, computers that we have, but they are working in close synchronization. Whereas in the previous iteration of this, in the industrial age 3.0, the computers and automation, they work only through a narrow interface. But now increasingly with IoT is cyber physical, right? Because both the AI as well as the the computers as well as the physical devices, they work seamlessly together. But with the super smart society, it's not just the industry, but actually we are actually talking about the boundary between both the cyber and physical world is sort of merged together. So it's a super smart virtual fabric where the division between, clear division between the cyber and physical world would somewhat be removed, right? Because it's just a continuous fabric now rather than a very clear division between cyber and physical, which we still see in the Industry 4.0. So it's really the extension of the concepts that are started with Industry 4.0 being extended in to a larger segment of the world, the entire society. And also the other thing is that the sort of division between cyber and physical will be more fuzzy in the Society 5.0. And we'll talk a little bit more about that afterwards. So as you can see some goals between Society 4.0, which is our present society, versus Society 5.0. So you can see that one of the things that we try to do is actually to achieve more sustainability, more resilience, more diversity and decentralization. Also trying to optimize not over at the individual level, but at a societal level, right? So the applications for AI is not just for me as a person, as the individual, but how do we actually take advantage of this capability to enhance a society as a whole. So here we see one of the differences between the two. So for the traditional Society 4.0, there's still a clear division between the cloud, or what's in the virtual space, and the physical space, which you had humans and other devices like robots and IoT is in. It is still a person who needs to analyze that information, retrieve the information, and then make decisions. So the physical space and the cyberspace is still very clearly delineated. But with society, just like AIoT, right, the division between the two is sort of merged now. So various information is just sent up into the AI cloud, which collects the information and analyzes this data And then decisions that are made here would sort of be translated into some physical effect in the real world. So physical space and cyberspace, you can see that the border, which was very distinct in Society 4.0, becomes a lot less distinct in Society 5.0, and it's more just part of the entire continuous cycle. So what are some of the advantages that we do anticipate in Society 5.0 is that in Society 5.0, you will see that some of the various social issues that we have with aging, we can use advanced robotics and AI to try to make society better for the aging population. In terms of reducing human workload, human labor, right? We can go to an age where automation will be much more widespread. So it's no longer necessary for you to drive your own car, for example. The cars can drive themselves. A lot of information overload in the present society, but in the AI cloud environment of the future, as we're growing now, humans will be freed from the normal routine decision making, because in just like what I mentioned, in the AIoT cycle, the humans do not need to be involved in every single decision, right? So some decisions between after processing the commands to do various controls can just be automatically taken by the AI system itself. Humans will still be involved, but maybe more for the exceptional cases where some other contexts need to be considered. And I'll talk a little bit more about this in the next, in the module 3, when we talk about AI and AI systems in general. What are some of the advantages of AI and versus what humans are very good at? So we are not thinking about removing humans altogether, but we just want to free humans from some of the burdens that they have to bear now, because there's no assistance technology or technology that can assist them in doing some of this processing. And knowledge and information will be much more widespread because of these capabilities. But some of the ecosystem that we see now supporting the AIoT, so that we know that the enablers are there. We know that they are going to support two big changes in society. One is the Industrial Revolution 4.0 and also the Society 5.0. What is currently in the AI ecosystem? So you can see that actually in terms of AI processors or AIoT devices, the US still has its very well-known brand names, Intel, Qualcomm, Google, NVIDIA, producing this kind of more sophisticated AIoT devices and processing chips. But actually, you also see that there's a big rise of capability from China itself. So Huawei, E2, Baidu, and even the Alibaba group, they have actually hardware devices that they are actually working on. And the rest of the world, like the Japanese and other companies like the UK, Israel, they are also producing some of these AIoT processing capability in the form of chipsets and CPU processing capability. So this is a global ecosystem that's actually evolving. In terms of cloud capability, I'll talk a little bit more about this in the 4th module when we talk specifically about cloud AI, but we do see some very famous brand names here. So we have the AWS, Amazon, having the IoT services built into its cloud, and then we have Azure from Microsoft, and then we have IBM, Watson's capability, and of course Google or Alphabet also has this capability. So these are the four big cloud providers, and I'll talk a little bit more about the other cloud providers from China. They're also emerging in this space as well in the 4th module. So with that, we come to the end of the last topic that we have. Thank you very much.